Hi you guys, welcome back to my channel, and today we're going to be talking about 45, 45, 90 triangles. So 45, 45, 90 triangles are a special type of triangle that we have where if we know one side of the triangle, we're able to find any other side of the triangle. This triangle comes from a proof using Pythagorean Theorem. If I just draw our triangle here, it's a right triangle with two angles being 45. This is possible because we know that 45 plus 45 plus 90 equals 180 degrees, and each triangle has to have a total of 180 degrees inside of it. If I make each side equal to A, which we know the two legs have to be equal to each other because they're across from equal angles, and the hypotenuse H, we can do Pythagorean theorem to figure out how long H is going to be in relation to A. So we would do A squared plus A squared equals H squared. That's simplified to 2A squared equals H squared. And to get H by itself, we're going to take the square root of both sides. Because we have 2 times A in the square root, we're able to take out an A. Write that over here. We leave the 2 inside, and that's equal to, we have a pair of H's inside of the square root here, which means we can take out an H. So the hypotenuse is equal to A square root of 2. So that's the proof for how we get what this triangle is equal to. So how do we use this triangle to figure out what the lengths of the sides are in a triangle when they only give us one side? Well, we're going to do that like this. Let's say I have a triangle here, like a right triangle. I only need to say that one side is 45 because that'll show that the other side is 45. And let's say I say that this side down here is equal to 2. We want to find side X, and we want to find side Y. What I like to do is I like to set up a system of 3 equations. So we know that this side here is equal to that side. We know that this side here is equal to that side. And we know that the hypotenuse is equal to the hypotenuse there. So just write that those are all equal to each other. So we have A equals 2. We have A equals X. And we have A root 2 is equal to Y. So now we're going to go to which one of these equations only has one variable in it, which would be the first one here. And we have that A is equal to 2. So now all we need to do is plug in 2 everywhere else we see A in the rest of our equations. So X is equal to A. That means X is also equal to 2. And Y is equal to A root 2, which means Y is equal to 2 root 2. And now we know all the sides of our triangle. Let's try another one. Let's say I give you this time the hypotenuse is equal to 10 root 2. And I want you to find one of the legs and the other leg. So then we would set up our equations again. We know that this side is equal to this side. So A is equal to X. We know that this side is equal to this side. So A is equal to Y. And we know that this side is equal to this side. So we know that A root 2 is equal to 10 root 2. So now we're going to go to our equation, which only has one variable in it, which is going to be this bottom one. And this time we have to solve for A. So we're going to divide each side by the square root of 2 in order to get A by itself. Here, the square roots of 2 cancel out, and they do over here as well. So we get A is equal to 10. Now plug that in for A in the rest of our equations. So here we get X is equal to 10, and we get that Y is also equal to 10. Let's try one that's a little bit harder. Let's say I give you that the hypotenuse is equal to 7, and I want you to find side x, and I also want you to find side y. So we're going to set everything equal to each other that we know is equal to each other. So we're going to set a equal to x, we're going to set a equal to y, and we're going to set a root 2 equal to 7. And just like before, we're going to go to the equation that only has one variable in it, which is the one focusing on our hypotenuses. I'm going to rewrite that over here. A root 2 is equal to 7. And now I have to get a by itself. So we're going to divide through both sides by the square root of 2. And we would get a is equal to 7 over the square root of 2. However, we don't like to have square roots in the bottom, do we? We always want to rationalize our functions to get rid of any roots we have in the bottom. The way we rationalize is we're going to multiply both the top and the bottom by the square root of 2. Because we're multiplying the top and the bottom by the same thing, that's essentially multiplying by 1. So that's why we're allowed to do that, because if we multiply by 1, we're not changing the overall value of the equation. So on top, we're going to get 7 times the square root of 2, and on the bottom, we're going to have square root of 2 times square root of 2, which is just 2. So we get that a is equal to 7 root 2 over 2. So that tells us that x is also equal to 7 root 2 over 2, and y is also equal to 7 root 2 over 2. Let's try some practice problems. If I give you that the hypotenuse is equal to 8 root 2, can you give me what side x is equal to and what side y is equal to? Give you a few minutes to try that on your own. You can pause the video now and come back to it when you're done. Okay, so we're going to start this problem by setting each of the sides we know are equal to each other. So a and x are equal, so we're going to do a is equal to x. We also know that a and y are equal, so we're going to do a is equal to y. And we also know that a root 2 and 8 root 2 are equal. So we're going to go to the equation that only has one variable in it. So that's going to be a root 2 is equal to 8 root 2. And you should have gotten, once you divide through by root 2, that a is equal to 8. And because of that, x is equal to 8 and y is equal to 8. Let's try another one. If I give you that the hypotenuse is equal to 6, can you tell me what side x is and what side y is? Pause the video now and come back when you're done. So we're going to set this up the same way as all the other ones. Set equal sides equal to each other. So x is equal to a, y is equal to a, and 6 is equal to a root 2. We're going to go to our formula, which only has one variable in it, which is 6 is equal to a root 2, and we're going to solve for a. So we're going to divide both sides by the square root of 2. They're going to cancel out over here, and we're going to have to rationalize this 6 over the square root of 2. So we're going to multiply the top and the bottom by root 2, and on top you're going to get 6 root 2 over 2 is equal to a. Now we can reduce this. 2 goes both into 6 and 2. 2 goes into 6 3 times, and 2 goes into 2 once. So your final answer is going to be a is equal to 3 root 2, which means that x is also equal to 3 root 2, and y is equal to 3 root 2. I'm going to do one last practice problem. So lastly, if I give you that one side is equal to 5, can you tell me what the other side is and what the hypotenuse is? We're going to start, like with every other one, set what we know is equal to each other equal. So 5 equals a, x equals a, and a root 2 equals y. This one we already have a solved for, so we can just plug that into the rest of our equations. So x is equal to 5 as well, and y is equal to 5 times the square root of 2. This has been learning how to solve 45, 45, 90 triangles.